In this presentation, we're going to be exploring the options for cutting 3D parts that cannot be finished with a single 3-axis approach. So let's run through the agenda for this presentation. So this really is an introduction or a study to multi-sided machining. We're going to examine the different approaches to machining multi-sided parts. We'll also be discussing the limitations or the problems that may arise when machining parts that have more than one side. We'll have a look at 3 demonstrations. There'll be the Self Aligning Jig, and we'll look at 4-sided machining just using 2D toolpaths, and 4-sided machining where we import third-party 3D data. So what is a multi-sided part? Now, a multi-sided part is anything that has more than one face. So let's have a look at some examples. So here we have the Cool Cubes project. This is a tutorial on 2-sided machining that we have with the software. It is also available as a project of the month. Now the cool thing about this is that you can see on the image on the left hand side we've got these cubes that have decoration on each face of that cube, and then if we take a look on the right hand side and take a look at this image here, you can see that this is actually the underside, and we have toolpaths here that enable us to assemble the cool cubes. So here's the top side and here is the underside. Then we have another example of 2-sided machining. This is the Love Spoon. This can be found on the Vectric Labs website at vectriclabs.blogspot.co.uk. It's just another way in which we can utilise multi-sided machining to create parts like this spoon here. Then we have another project. So this is another project of the month, and this is how to make a wooden chain. And again, this is just simple 2-sided machining. So the natural step from progressing from single-sided machining is to work your way up and start with 2-sided machining. And so you can see that just using 2-sided machining we can make some really interesting projects. And we will be discussing 2-sided machining later on within this presentation. So let's have a look at some more examples. So here we have a 3-sided part. This is a core ball that has a front face and 2 sides. Then there's Rotary. Then we have a customer, Russell Crawford, who has kindly posted this on the forum. We actually did a case study with Russell on the Maloof chair. Now this Maloof chair is made up of a combination of single, 2-sided and 3-sided parts and then assembled together. And so you can really see how you can make relatively easy to quite complex looking parts like this here using multi-sided machining. Then there's more complex work that people have made. So a customer on the forum under the name Snowgrains created this really cool full life-size 3D model of this Rocketeer. This was done using the slicing feature within Cut 3D. So why should we cut multi-sided? Firstly, we're able to make more interesting projects than regular one-sided parts. For example, we can create toys, furniture, household objects. You could also take a standard sign or a plaque and turn that into a 2-sided part, where you add toolpaths to the underside in order for you to fix the part to a wall, for example. Now if you think about it, most things have more than one side. And so understanding how you can approach multi-sided machining makes your machine a lot more flexible. And so we'll be discussing the different approaches and things to consider with machining multi-sided parts within this presentation. Now before we think about how we can tackle multi-sided jobs, let's just take a moment to think about some of the things that we're concerned with when cutting a standard single-sided job. Now firstly, we always ensure that the software setup matches the physical setup of the material block and the positions on the machine bed. So we're looking at the size of the part, the material, and our X, Y and Z positions. Secondly, we think about the physical limitations. So we think about the tools we're using, the size of them, and making sure that they're safe to use with the material that we're working with, where we would consider how much Z depth we have to cut. So what do we need to think about when dealing with parts that have multi-sides? First is our alignment. So how do we get accurate registration for each side? And more importantly, how can we do that when we can only preview a single side at a time within the software? Then we need to think about the material. So material is another key thing to think about when dealing with multi-sided machining. So we need to think about the size of our material and be wary of the limitations when cutting a block of material. So that's thinking about your tool size and the amount of space that you have to cut a block of material. Then we also need to think about how we hold the part down. And so we'll be talking a lot about the alignment and our material with multi-sided parts throughout this presentation with the different examples we'll be looking at. So let's have a look at some of the techniques we're going to be discussing. We're going to look at assembly, wrapped rotary machining, two-sided machining, and then 3, 4 or more sided machining. So let's have a look at the techniques for assembly. Now one way is by taking a model and creating a mirrored copy of that in the same session, where we'd cut that out on a single side of a piece of material and then glue the two halves together. Another way, if you remember the core ball that we looked at earlier, we could take a part that has a front face and then create sides for that and then cut them all in separate sessions and then glue them all together. Another way we could create full 3D parts is by using Z slicing, so looking at the slicing feature in the software, cut the parts out and then glue everything back together to get your full 3D model. And then there's slicing with using third-party software, and that will enable you to slice at various depths and angles. So the shark example you can see at the bottom is done by one of our customers, Jamie Oxenham, who uses this third-party software but then brings the slices back into Vectric software to cut that out. So what are the things to consider with the assembly process? So the first one is that we can cut it in one operation. However, when we start to assemble the parts together or glue them together, we may have an issue with the grain match. It's probably not going to match up as you'd want it to. So there is a lot of manual tidying up to do with the gluing process. However, that's relatively easy to just toolpath and glue together. Then we have the rotary axis and the indexer. So the rotary axis takes the X or Y movement and replaces it with a rotational motion. And so you can take a design and wrap it around a column, and you can unwrap 3D models. Indexing takes standard 3-axis toolpaths in which the rotation needs to be manually added between each side. Then we have two-sided machining. So what's the process for two-sided machining? Well, this is where we take one side, and so we carve the model into one side of material, and then we flip the part over, and then we machine the other side. So the key here is to get the correct alignment on both sides. So how do we do that? Well, let's have a look at some alignment methods. So one, we've got the dowel method. We can do this in a symmetrical fashion or a non-symmetrical fashion. Then there's also the jig, so you could use a table jig or a self-aligning jig. And there are probably others methods available, but we're going to look at discussing the dowel method and the self-aligning jig method. So let's have a look at the symmetrical dowel method. So the way we do this is we draw circles in the software that represent our dowel holes, and we place them symmetrically in the job. We then mirror that job about the centre to create the other side. And so this is quite a quick process in that we just drill the dowel holes all the way through the material, but we just need to be aware or need to remember which way we flipped the part in the software, and then repeat that process physically with our material block on the machine bed. So let's have a look at the non-symmetrical dowel method. So we start by creating an odd number of randomly placed dowel circles within our job. And so when we come to create the underside or side B, what we do is we mirror everything about the job centre so that we get correct alignment. Now in terms of the dowel holes for side A, we partially drill through the material block, And then for side B, with the mirrored dowels, what we do is we just machine those holes into the spoil board. So you can see in that image there, you can see those holes within the spoil board, and we can see where the dowels are within our block of material. And then so that allows us to have perfect alignment. It also gives us the ability to machine side 2 at a later date. Another way that we can keep our part aligned in two-sided machining is by creating a self-aligned jig. And so using an asymmetrical stepped shape, we can easily create this self-aligning jig. And now the key here is that the size of the steps, so these areas that stick out here, the amount that they step out is determined by the tool that we plan to use. And so when you mirror that over physically and flip the part over, it will lock into its own profiled shape. So let's take a look at this process in action. Now this video is courtesy of Brian Altrog from Grundblau Design Studio. You can access that on YouTube if you just search for two-sided soap dish or follow the link at the bottom of this screen. And so you can see that the tool is currently going around creating that profile toolpath. So it's just following the vectors, so for example like the vectors that you can see at the top of the screen in the image there. And so once that's cut out, then Brian is going to take that part out. Just give that a clean up to begin with. And take the soap dish out, clean inside of that jig area there. So you can see now we've created this jig shape. And so what will happen now is we'll put the soap dish in, however we're going to flip that over horizontally. Okay, so there's the original side that we just cut, flip that over horizontally, and then we can see that that is going to fit snug within that jig shape. Okay, and so you can see that it is just self-referencing. And so this method is just a real quick and easy way of aligning a two-sided part. And so we're going to look at this in the self-aligning jig tutorial. So in the self-aligning jig tutorial, we're going to start by drawing a rectangle. And this rectangle is going to form the basis of our jig, which we'll look at using the guidelines to help us draw this. So we're going to use a 1/4 inch end mill in this case to profile our self-aligning jig. And so what I'm going to do is I'm going to insert some guidelines. We're going to start by creating guidelines that are going to come out 1/4 inch from each side of our rectangle, and then I'm also going to create some more guides that are going to divide up the jig area evenly so that we can create our stepped shapes. So we're going to use these guides and then start drawing our steps using the polyline tool. Once we've done that, we'll then run a profile toolpath, and the key here is to use the solid preview option where we can see the areas that are going to be cut away in the 2D view, and so you can see that highlighted there in this image. And so with that preview, what that enables us to do is to take the original vector, and then we can use the mirror and flip option, and we can see that that will fit within that profile shaped perfectly. And so this really is a cool and smart way of aligning a two-sided part. So if you're wanting to try this, then please go and watch the self-aligning jig tutorial. So that's one method of using a jig. Other jigs that we could use are making temporary jigs in the software, so you can make them to exact measurements. So we could look at making profile shapes. We could look at using the pocket toolpath, so we could create a pocket to the size of your block of material for your block of material to sit within. And the tutorials that I'll be demonstrating will be using this method of using the pocket to create our jigs. Then there's right angled jigs, and then there's fixed jig position on your machine. So far we've spoke about assembly, how we can assemble parts to create multi-sided parts. We've also looked at rotary and two-sided parts. Let's have a look at multi-sided parts, so anything that has more than two sides. So the main difference when working with multi-sided parts is thinking about the depth. Okay, so when you introduce another side, you've got another depth to think about when you turn that block of material on its side. So we need to always think about the depths of our part, and then ultimately we need to think about, well, is that going to affect our tool access limitations? Because once we've turned a block of material over, and then this could be sort of the highest depth that we're working with, because that was ultimately the width of one face, and now we've turned the block of material on its side, that width now becomes the height. And so we need to think about things such as the tool axis limitations, so thinking about your material height, and especially the z-depth between the gantry, the collet, the tool and the surface of the material. And so we'll be discussing some of these things within the St Hugh tutorial, as this demonstrates how when you turn block of material over on the side, you now have a lot more height to work with. And so we need to think about ways that we can overcome the amount of space that we're working with for our tool to get into, to ensure that we're doing safe cutting. So next thing we need to think about is our alignment. How do we get correct alignment when we're working with more than two sides? And so the key here is, to begin with, by helping yourself out, is to machine your block of material to the exact size, or just about the same size as the parts that you're planning to cut. Okay, and so this ensures that when we have this block, we can then sort of work out what jig that we can create in order for us to get the correct alignment, which we'll be talking about shortly. So how can we get our material block cut to the exact size? Now you could do this manually in the workshop, or you could buy pre-prep material, but the most accurate way you're going to get this to be the exact size is just by doing that on your CNC machine. So you could look at planing the material down and then running profile toolpaths to ensure that you get the exact dimensions of the part that you want to cut. So how do we keep the part held down and keep everything aligned? Well, the best way that I've found is by using a pocket jig. Okay, and we'll be discussing how we create these pocket jigs in the Clock Tower and the St Hugh tutorials. And so what we know already is our block of material that we're working with. As we mentioned, we need to work with accurately sized material. Okay, now that block of material that we're going to work with is going to determine the size of our pocket. We want to make that exactly the same size as the material that we're using in order for us to create our pocket. So that's one thing. We also want to make sure that we set our XY positions in the same position for our pocket as with the file that we're working with. And again, you're going to see that demonstrated both in the Clock Tower and the St Hugh tutorials that follow this video. And that is the key for getting everything aligned. Once we've got our XY position set up, say we've got it in the lower left hand corner of our pocket here, we're going to set that up exactly the same for our file. That's going to be in the lower left hand corner here. So every time we turn our block of material over, everything's going to be aligned, because it's all referencing from this lower left hand corner where we cut our pocket from originally. So now we're going to look at two tutorials that follow this video. So we're going to look at four-sided machining. One tutorial is called Clock Tower. We'll be looking at creating this clock tower that you can see here, a full 3D model that's created just by using 2D, 2.5D toolpaths alone. We'll then look at how we can create this St Hugh model here. So we're going to create a full 3D model, full-sided machining, and we'll be looking at how we import the STL model and how we set up all of the model along with the toolpaths to create the full 3D part. So let's begin by looking at the clock tower. So as I said, we're going to look at creating a full 3D clock tower just by using 2D, 2.5D toolpaths. So how are we going to start this? Well, we're going to work with a block of material that's going to be 1.5 inches by 12 inches by 1.5 inches. Okay, so that is the first key point to remember here. That is the exact block that we're working with. So we're going to open the vector file and we're just going to walk through some of the vectors here. And one of the key vectors that we point out to begin with is the pocket. So you can see this pocket is going around the outside of our job setup. Now this job setup represents this block of material that we're working with. So we must create our jig first. So this is our jig. And we talked through this in the tutorial. And the idea of that is that we then go ahead and cut that out, and our block of material is going to sit inside of that jig. Once we've created that pocket and our block of materials in there, we will then run the toolpaths to cut the part out, well, at least cut one side of our material. And because we've set everything up exactly the same for our jig along with our file, where our XY is going to be in the lower left hand corner here, this is the key to getting everything aligned. So we must make sure that XY is at the bottom here in both the pocket, because we create the pocket in a separate session to the jig ultimately. Well, we create it in the same session, however we just save them out as two separate files. But the key is that we have XY is at the lower left hand corner in both of those, and that's to ensure that every time we turn that block of material over, we're going to get correct alignment on all four sides. That's the key thing in this demonstration. Okay, so here's our jig that we'll cut out. So cut the jig out, and then here's an actual photograph of the block of material sat in the jig there. And you can see we've just got some extra reinforcement just as a safety measure for this example. Okay, and so then what we'd do is we'd run those 2D toolpaths, and then we'd look at manually hand finishing the tower, and this is the finished part. So you can go to that tutorial now if you wanted to. So that's the clock tower tutorial. So now let's have a look at another example of four-sided machining. We're going to look at St Hugh. So this example, we're just going to be looking at importing 3D data. So we're going to start by setting up our material. Now we're working with a material block, again with pre-sizes. I've already cut this out on the CNC machine. It's 3 inches wide, 12 inches long, 1.5 inches thick. Okay. And so the first thing we need to do is make sure that we create that pocket. So we're going to use the jig method again. So we're going to create the pocket at 3 inches wide, 12 inches long, and then we're going to pocket that out in a separate session. And then in our session for St Hugh, we're going to import the STL model. Now this model is courtesy of lincoln3dscans.co.uk, so you can access that there. It is also available in the project folder as well. And so once we've imported the STL, we need to set up our orientation. So this is where we look at positioning the model within the virtual material block. And so this is where we decide whether we're going to use the top, the bottom, the right, front, back or left. Then the most important thing in this example here is setting up our model size. Now we know that we're working with 12 inches in length, so that's going to be our longest point, but we're not going to use all of that 12 inches because we want to make sure that we have areas at the top and at the bottom here that are untouched in order for the block of material to remain in contact within that pocket. Okay, so that's important that we have these contact points at the top and the bottom. So we're going to make sure that we have we're going to go with a Y value of 8 inches, the X is going to be 2.7, and then we're going to have a Z value of 1.4. Okay, so we're having that 2.7 just to ensure that we've got some space to cut around the side of St Hugh, and then the 1.4 is the position in the middle, the position of the model within our material block. So we're going to have a gap above 0.05 and a gap below of 0.05, and this will all be explained in the tutorial. And then we're going to position the zero plane within the model and push that all the way down to the bottom so we have the whole of the front side of St Hugh visible. So once we've got St Hugh in place, we need to add rectangular tabs to the model to hold the model to the material block. And so we'll be looking at the 3D tabs, and you have access to a folder in the project folder called 3D tabs that has all of the different component tabs that we can use to do two or many-sided machining with. Okay, so we're going to hold him in place using those tabs, and then we're going to run through the toolpath. So we're going to look at pocketing the jig shape to begin with. We'll look at the material setup for St Hugh. So we'll make sure that he's set within the centre of our material. Then we're going to go and look at pocketing that excess material around the side of St Hugh just to remove that. We'll look at running a 3D roughing toolpath along with 3D finishing toolpath, and that is the first side complete. And so then what we'd do in the physical world is we'd take that block of material, we're going to turn it over 180 degrees so that we have the back side showing. Now in the software we need to think about doing the back side, so we need to open up a new session for the back. I'm going to work with the same job setup. I'm going to import that STL model. Okay, so we're going to go through that orientate model form, and then we're going to add in those tabs. We're just going to copy the tabs from the top side and paste them into this session to get the correct alignment for the back side. And then again, we're just going to go through those toolpaths. So we'll look at the material setup, model position within material, we'll run 3D roughing and a 3D finishing toolpath to cut the back side of St Hugh. So that's the top and the bottom all done. So now I need to think about cutting the sides of St Hugh. So what we need to do is physically turn the part over 90 degrees, and we need to do that in the software as well. So we need to create a new job, but we're going to change the job setup. So now where the depth was 1.5, that is now the width of the part. And where the width of the part was 3 inches, that is now the depth. So we need to change those. And then we also need to make a new pocket jig, okay, because we can't use the jig we've already created because that's going to be too big for the side of our block of material. So we need to create a brand new jig exactly the same way that we created the jig for the top and the bottom. Then we'll then import the STL model. We'll set up the orientation, so looking at the left or the right this time. Again, we're going to make sure that the model size is all exactly the same. However, we just need to account for the depth changes. So the depth is now 2.7 and the width is now 1.4. Zero plane right at the bottom again, and then we could go and then position the tabs to match the front and the back sides. Now one thing we need to think about is now that we've turned our block of material over to its side, we now have the depth at 3 inches, and that's quite deep for most regular tools. So we need to think about this sort of limitation and how we can overcome this. And the way we're going to do it in this session is by adding a zero plane that's going to come up halfway. So we're going to make that 1.35 inches. So we're just working with half of the side, and that means that the tool should be safe enough to come down and cut half of the side of St Hugh. Okay, so that's that zero plane is there just purely to accommodate for our tool limitations. So we have to think about all of these different things. We'll then run through our toolpath setup. So again, model position and material, going to make sure that that matches up to what we've done on the top and the bottom. So making sure that that is in the dead center of our block of material. We're going to run 3D roughing toolpath and a 3D finishing toolpath, and then we'd essentially repeat the same process for the flipped side, and you'll see all of that in the tutorial. So I've just quickly ran through the process here, but the tutorials do demonstrate everything in a lot more detail. And so that completes this presentation where we've looked at lots of different approaches to machining multi-sided parts. We've looked at how we can assemble parts to create a multi-sided part. We've looked at various different ways to do two-sided machining. And then we've moved on and looked at how we can create four-sided parts, looking at using just 2D toolpaths to create the clock tower, and then we've looked at how we can import an STL model to cut the full 3D model of St Hugh. And so multi-sided machining is actually quite easy once you consider the options that are there. Okay, so you got to think about how big your part is. How are you going to align it, and how are you going to hold it down and keep that part aligned? And so choose the most appropriate method for you. And this really does widen the horizons for more work. You can create real interesting projects by introducing more sides to your parts. So go play and push the limits. Thank you for watching.